There we go. So you might be able to see on the room video. So I share some slides. Mainly when I start sharing slides, Zoom doesn't think I want to see you anymore, so.
It's you know.
Well, I can see the slides, but I can't see them. Yes. So I scheduled several little notionally 15-minute talks with the idea that we would have time in between to actually discuss. And so you should feel reasonably free to interrupt as things go. So what is the idea here? So we're gathered here today because we all care one way or another about C functional correctness verification. And this is still crucial, and it's still a major research problem, but it's still harder than we would like, I think we have to admit. So, well, it's harder than we would like, and it's quite hard to even understand the state of the art. So Neil and I, it's not coming back. Neil will come back. So Neil Krishnaswamy and Christopher Poulter, Sewell and Proof of Content, and I have been doing a bit of work on some C verification tool. We've been trying to read the literature, and it's not very easy to read the literature because there are so many approaches, all very different from each other. It's not always super clear exactly what the current strengths or weaknesses or future plans are. And it's not, in general, I think, the case that as a field we have an overview, like a shared mutual understanding of the design challenges and the best solutions. We have a bunch of solutions, and some of them worked impressively well, but the trade-offs and the choices are not maybe as clear as they might be. So the idea here is to see whether we can establish a better comparison and shared understanding of the design space. This is, of course, by no means the first comparison and verification tools ever, not even slightly. So in the automated tool space, well, okay, could explain in great detail, but there have been many very successful competitions, and those have helped drive that field. The interactive tools is kind of harder, but still, so there have been at least these, probably others that I don't know about. Craig is here, might speak to this first one. But none of these, I mean, all of these are good in their way, but none of them are exactly hitting the target that at least I'm aiming for here. So what I would like to end up with, not today, but in the medium future, near future, is first something quite lightweight. I think any of us have the spare time or effort to do separate assessments. So we imagine maybe just a shared repo that people could add things to. We aim to expose the comparison in this very highly multidimensional space, not have a competition exactly, because, well, A, I don't think we have the spare effort to do judging, and B, it may be counterproductive to do scores for winners in such a small community. So this is a difference from the automated tool space. And then we aim not just to understand what tools can do, but to understand how they work. And of course, to stimulate future research.
So, what metrics do you think might be valuable here?
Well, so here are some possible mechanisms.
Metrics?
Well, metrics, I'm not sure, are maximally valuable. So here are some possible mechanisms. Because it is such a highly multidimensional space, one tool might be great for all kinds of verification, but not cover.
No, I was interested in the dimensions. What dimensions?
Well, okay. That we should get to. So there are many dimensions. So one is itself a multidimensional space of the C language features, idioms that are supported. So one tool might be great, but not not let you verify anything about code that does integer pointer casts, because it uses a more abstract model. One tool, actually many tools, might not have any support for floating points, and others might. One might be very good at verifying integer numeric code, but not good at reasoning about fancy ownership disciplines. One might be totally lovely for examples of size up to 10 lines, and then scale miserably when you go beyond that. One might need extremely high expertise, one might need only moderately extremely high expertise. One might be highly faithful to the ISO-C semantics, and another might be rather ad hoc, maybe for targeting something else on purpose.
How would you unify on the assertion language? So, these different tools actually have different assertion languages, different variants of separation logic, maybe no separation logic.
Yeah. So then I think we can't in the first instance unify on assertion language. We can unify on the source programs and the intended specs written in code, or maybe in one language which
The sound is not great, by the way.
Is it equally not great for me and for Shankar?
Can you hear me now?
Now I can hear you, yes. But I think it's when you're talking at the same time, mostly.
So in particular, the microphones are there, right?
Yeah.
So there's a bit of a risk that if we talk to each other, then you're not going to get us.
Yes, we can also.
Did you hear Thomas just now?
No, I've lost him entirely.
Yep. I think there's a risk that the noise cancellation algorithms will cancel everyone if multiple people are speaking.
We will try to be very, very simplex. See if that helps. And we'll try and shout a little bit and aim our heads vaguely at the microphone. Greg says this is better.
That helps, yes.
Although I moved the microphone closer, proportionally more to me than to everybody else. So just through geometry.
We should make a round sound check, right? Everybody says hello.
Well, I mean, Peter does have the strongest opinions about the C programming language.
It's true, but not justified strong opinions about its verification. Yeah, so there's a lot of these dimensions. And one of the things that I would hope to end up with, again, not necessarily today, but over the near term, is a nice list of those dimensions that we all think is a good one. I brainstormed to myself a list of C features, and I ended up with like 25 different features that you might want to indicate. And some of them are not Boolean. Like for some of them, you might want to say, for the memory object model pointer, integer pointer question, we choose this semantics. It's not a yes/no question. So for that, you might imagine ending up with a table that has 35 dimensions and short answers for each tool. And that would be a useful thing. That's this third bullet on this slide. And one thing you might do is just have these talks, which might really be very useful. Another thing you might have is a small-ish collection of small-ish examples. So I say this, this is quite delicate, right? Because there's no way that here we could handle the sort of SV comp scale of automated example evaluation. And you want examples which, on one hand, it's nice to exercise scaling, but on the other hand, you want examples that won't take a whole project to come up with a solution for. So there's some delicate balance to be gained from making this, or in making this list of examples. Small enough for the solutions to not be too much work, I say that. And another thing that I think is maybe quite important is to aim not just for, can this tool solve this challenge And if so, in what smallest possible number of lines or smallest possible number of minutes, but to aim for instructive solutions. Can this please show us maybe the shortest solution in your tool for this problem, but also the most instructive solution, and explain using it how the tool is working with the hood. So this is more demanding for authors because they have to write something. For some tools, they've written something like this in their documentation already, some they haven't. It would be nice to have for 2 or 3 examples that have that done for the same examples across all the existing tools. And then maybe some larger ones, 1 or 2, to look at the scaling. So this is sort of what I came up with off the top of my head, and after talking a bit with Andrew and some other people at the previous DSO event, but I'm very open to suggestions and refutations and better ideas. Okay.
So what is the problem with these automated peer tools that no competition and no judgment? I mean, I believe that their motivation is to scale their tools for the various challenges in C. So why not the same thing for same here?
But because I think it's just, I mean, you have SV comp has like 1,000 C examples or something. There's the answer. Like we can't practically do that. And in some sense also it's not, I mean, it would be insightful to do that if we could, but it wouldn't do this explaining. It wouldn't get people to reflect and to explain to the rest of us how the tools are doing things and what the limitations are. So A, we can't, and B, making the best of the unfortunate reality, we can aim for some other thing instead.
I think it could be very unwise to select examples from that sort of set of benchmarks, because those examples are the examples for which automated theorem proving works well. So actually, you would be shooting yourself in the foot, right?
Well, it would be interesting to have
in a sense, the idea would be to find the smallest examples for which the automated tools fail, and for which you can find elegant solutions.
Well, one point though is even in an automated tool, you want some degree of automation. So these might be a good benchmark for. Are you at least as good?
Yeah. So I think it would be nice to select a quite small, quite carefully curated subset of those automated tool benchmarks, in addition to those of the other kinds.
So I see the important point in the interactive and deductive verification tools. They are working on small examples and show the world, what is possible. And then we, the automatic tool guys, we try to implement as much of this and automate as much as possible, right? So I agree completely that the problem of scaling should not be the focus of this set of examples, but the examples should be showcases of interesting problems. And then basically, if this is communicated between the communities, then maybe in the automatic tool developers, they will look at these examples, how can we basically automate the verification process that is interactively done with this or that tool, right?
Yeah, and so that would be a good benefit.
So, but the connection between the two benchmark sets, I also would I think it's fascinating if there are programs taken from this existing benchmark set, which maybe the automatic tools cannot yet solve, and solve them with interactive as a challenge for the automatic tools, right? So here is how you can solve it. You just need to make it automatic.
Yeah.
I just want to toss in, sorry guys, there's several hands up, Zhang Xiao and Andrew, and we're also, I think, a little over time. I don't know how.
Currently over time. So this is a terrible feature of Zoom, that because I'm presenting, I can't see anybody's hands.
You can see it on the screen.
I can't because I have my close-up glasses on.
Oh, okay.
Zhang Xiao's had his hand up for the longest, so maybe Zhang, you can chime
Yeah,
in.
go ahead. Thank you.
All right, okay, so maybe we should define the problem a little bit more clearly. I understand the focus is verifying system code. So lots of system code involve concurrency, and C language does not really offer any reasonable concurrency models. So some notion of like what is the target machine you guys have in mind, and also system code involve device and so on, different form of concurrency interrupts, IO, and so on. So lots of interesting example could lie in that domain. So maybe some some elements of machine spec or concurrency model should be part of the game, basically.
Yeah. Andrew? Or
I think I'll save my remarks for the next talk, which is
Okay.
mine. So
all right. I second what Zhang Zhang said. But maybe we should start the next talk and
Let me just stop sharing so I can see what's going on. So just to reply quickly to Jean, so I think I would wish to prescribe which concurrency model because there are some tools are not supporting any of the real ones, or some not at all, and there's a lot of choice there. So one might want to, it might be that we should just focus on the sequential world just for the sake of.
I just mentioned it should be a dimension of this discussion, right?
So it should certainly be a dimension of this discussion. Whether one should try and make examples that exercise it, one could. Maybe we should. I'm not against it.
absolutely, we should.
Something to consider. But as somebody or other, Gregory said, we should indeed get started. So I've carefully scheduled, some gaps between the talks, but I foresee we will amply consume those gaps with chit chat. So whoever it is that's first should present.
I think that's me. Is that right?
I think I adopted